everyone. Thank you so much for joining me today. I am Vasya Krishnan, and I work as a part of the SQL Enterprise PM team. In today's session, we will be talking about Azure SQL Edge and its features. Without any further ado, let's dive into it. The Internet of Things, or IoT, refers to the billions of physical devices around us that are connected to the Internet, constantly collecting and sharing data. Thanks to the arrival of super cheap computer chips and wireless networks around us, it is possible to turn anything, something as small as a button to something as large as an airplane, into an IoT device. Having said that, we will have 80 billion connected devices by 2025. And Gartner has stated that the compound annual growth rate in this data will be approximately 30%. And we're looking at 180 zettabytes of data. That is the 7th power of 1,000, or 10 to the power of 21. How many zeros is that? So connecting up all these different objects and adding sensors to them adds a level of digital intelligence to these devices. This opens up a wide range of IoT or edge scenarios across every major industry out there. Smart factories in manufacturing, remote medical assistance in healthcare, predictive maintenance of airplane parts, analyzing drone or satellite data in defense, autonomous vehicles, you need not talk more about it, point-of-sale devices with financials, monitoring wind farms, solar energy panels when it comes to energy, on-site inventory system in retail factory outlets, and finally, home security. As you can see, IoT is all around us. By collecting and mining data generated by devices at the network periphery or edge, as we know it, IoT holds the potential to increase business profits and improve customer lives. So before we talk about Azure SQL Edge, let's take a quick look on how IoT is transforming the healthcare industry, and then follow it up with how Azure SQL Edge can solve these problems. Healthcare providers have long struggled with several nagging problems. Most notably is their interactions with the patients, which are very sporadic, giving them little insight into daily decisions and activities that have a huge impact on patient health. Fortunately, IoT technology is a potential solution for today's concerns in the healthcare industry. Among healthcare workers who believe better experiences, deeper insights, and superior care is absolutely necessary to enable personalized medical care, empower care teams, and also improve operational outcomes, a whooping 89% say they are in the process of adopting IoT. A large number, which is about 85%, believe IoT is critical for success. And 78% want to apply IoT to all walks of their business. So the driving force behind this is to provide an enhanced patient care through rich insights. This brings me to benefits of analyzing data in the edge for the healthcare industry. First up, simultaneous reporting and monitoring. That is, real-time monitoring. Via these connected devices can actually save 1 million lives in the event of medical emergency. These connected devices on or around the patient can collect useful medical and health-related data, thereby playing a key role in medical diagnosis. Next up, end-to-end connectivity and hence affordability. The connected devices in healthcare enable deeper communication, information exchange, data movement, making delivery of healthcare services extremely cost-effective. And then data engineering and analysis. We keep talking about connected devices, and these devices bring with it real-time data through IoT-enabled devices. This data can be analyzed and segregated through mobility solutions powered by the edge technology. Having this constant data analysis can then in turn help with real-time tracking and alerts, especially life-threatening situations, thereby safeguarding a critical patient's health. All that we spoke till now will enable remote medical assistance. This can help patients get proper medical help on the go, irrespective of where they are located. We saw these amazing benefits, but with every benefit comes a challenge. Let's look at what challenges are encountered while analyzing healthcare data at the edge. One of the most significant challenges faced by IoT is data security and privacy. IoT-enabled mobile devices capture data in real time. there is a significant ambiguity when it comes to data ownership and regulation. Hence, data stored within IoT-enabled devices are prone to data thefts. Next is integration. There are multiple devices and protocols out there, which actually causes a hindrance in the implementation of IoT in the healthcare sector. Manufacturers haven't come to a consensus regarding these communication protocols. And what happened because of this is each manufacturer has their own IoT ecosystem of IoT devices. IoT devices also generate data in bulk, and there is a lot of data overload because of this. For proper data analysis, data needs to be segregated in chunks without overloading, thereby giving us accuracy, which is imperative to make these medical decisions. The IoT devices are heavily dependent on network, but network availability varies across the globe. Low bandwidth, high latency, low network availability, and high cost all play a crucial role here. While 5G is aimed at solving some of these problems, it will not be addressed globally. And then there is cost. You might not be surprised to see cost over here. Costs are one of the greater challenges when planning to consider IoT app development for healthcare mobility solutions. However, these costs are justified if the solution that's implemented solves a genuine problem. So Azure SQL Edge has been developed by keeping these challenges in mind. It is a database that is optimized for IoT deployments, built using the same SQL engine that is present on SQL Server and Azure SQL offerings. It provides the same industry-leading security and performance. Azure SQL Edge can be deployed on devices ranging from IoT devices to edge servers. When I say IoT devices, it requires a minimum of 2 cores and a few gigs of memory. It is a fully containerized solution that is compatible with most Docker container engines. It can run not only on x64 architecture, that is your Intel or AMD devices, but also on ARM64 devices such as your Raspberry Pi. It provides the same developer and tooling experience as that of SQL. Further, Azure SQL Edge supports connected, disconnected, and hybrid scenarios. In the connected scenario, Azure SQL Edge can be deployed as a module of the IoT Edge device. And in a disconnected scenario, Azure SQL Edge can be deployed as a standalone container. This Azure SQL Edge is now currently generally available for the public. And while it's based off of the same Microsoft SQL engine, we do bring to the table some unique features that plays a key role when it comes to edge deployments. Let's take a look at these features. Built-in time series, data streaming, and AI. Let's dissect this a little. SQL Edge includes native support for data streaming to and from multiple input and output targets. This is the same engine that powers Azure Stream Analytics. We currently support streaming through IoT Edge, IoT Hub, and Kafka. We are working on improving the source and target pairs that can be used for the streaming capabilities to and from SQL Edge. Next, time series capabilities. So when it comes to time series, it is twofold with Azure SQL Edge. We bring to you already existing time series capabilities in Azure Stream Analytics, such as windowing, aggregation, and anomaly detection. We also have added capabilities to SQL Engine around time series specific functions and storage optimizations. Next, we bring to the table built-in ML and AI capabilities. Azure SQL Edge supports Onyx runtime, which means you will first need to train your ML model with a framework of your choice and convert this model to Onyx format. Onyx is Open Neural Network Exchange. You can deploy this model on Azure SQL Edge and use inbuilt native scoring capabilities as well. What we're trying to achieve here is build and train your own ML model, be it on the cloud or on a data center, and deploy it to your Azure SQL Edge. The next thing is native data movement. So when it comes to IoT, you would want to store your data for longer periods of time for data analysis. Data can be moved through either at the streaming layer or in batch processing to various Azure targets. The targets could be Azure SQL DB, Azure Cosmos DB, data lake storage, etc. Azure SQL Edge currently supports bidirectional data movement. The next is your choice of platform. So I already touched upon a little about this before, where we support extended device architecture. By that, I mean we support x64-based architecture, your Intel or AMD devices, and also ARM64 architecture that you find on your Raspberry Pi. Next, you can choose either a Windows or a Linux-based device or host and use Kubernetes or Linux Docker containers to orchestrate your device infrastructure for better efficiency and automation. And finally, when it comes to architecture, one can run SQL Edge online or offline or hybrid to support various edge environments. Finally, unparalleled performance and security. Azure SQL Edge brings with it industry-leading security and performance with flexible business continuity and disaster recovery solutions. When it comes to security, we offer the same security as that's there on SQL Engine, which is transparent data encryption, always encrypted in capabilities, role-based access control or attribute-based access control, and definitely data classification, data masking, etc. In terms of performance, we have taken those properties that make SQL perform really good on containers, such as fast recovery, column store indexing, and compression enabled by default. Now that we have seen Azure SQL Edge and the numerous features it brings to the table, and we've also seen how IoT is influencing the healthcare landscape, let's look at Azure SQL Edge in action when it comes to a remote health monitoring system. We will see how a patient's ECG data is constantly monitored. In this scenario, she is someone who's suffering from a chronic heart disease, and she is in a remote location with sporadic internet connectivity. She carries with her a portable EKG monitor that constantly monitors her heart and classifies it as between normal to high risk. And this person, given her geographical location, does not have easy access to her primary care physician. Throughout the demo, we will be highlighting 5 key stages in the journey of our patient. That is, create, communicate, aggregate, analyze, and act. Let's now move to our demo environment. So what we have in front of us over here is a simulated device of what a portable EKG monitor is going to be sending in the form of a data. So this is the create stage, where a lot of patient-generated data comes to us in the form of these data points. The next step that we are supposed to be doing is actually taking all of that data and then communicating it to different devices as and when necessary. For that purpose, we have Azure SQL Edge, in this case, deployed as a standalone container. And all of this data is first being written to Kafka clusters. And this is what you are seeing over here in front of your screen now. So once this data is being written to Kafka clusters, we are going to be using built-in data streaming to send that data to Azure SQL Edge. Let's take a look at how that is going to be. So this query construct over here in terms of creating stream jobs, starting and stopping the stream job, this is what plays a key role in sending all of that data into Azure SQL Edge. When it comes to chronic disease management in remote healthcare monitoring systems, data streaming is very, very crucial to make the right decisions at the right time. Now that you've seen create and communicate, the next logical step is to aggregate all of that data and analyze that data that is coming in. For the purpose of analysis of data, what we're going to be doing is training an ML model. We are going to do a deep neural network model using MLP classifiers, and then push that model to Edge after being converted into Onyx runtime. Let's have a look at it. So this first cell that you see here is where we are actually loading a lot of libraries from Pandas and sklearn. This sklearn is essentially to get into all the required classifying algorithms for training. And the next thing we have is the Onyx ML tools and Onyx runtime. This is needed for converting the model to an Onyx runtime model before deploying it to Edge. After loading the data, what we are doing over here is upsampling the data. And the purpose of doing upsampling is to ensure equal representation of all categories of the heartbeat so that the model is trained without any bias. The next thing we would be doing is taking a part of the model into test. And so we are just splitting the data set into a training data set and test data set for future references. For the purpose of time, I've actually already run this particular model training over here. This is the place where we are training the model using multi-layer perceptron classifier. And I have set the iterations to 30. You could set in more than 30 for better accuracy. Let's take a look at the score of the model. It's about 89%, which is pretty good. We're just going to do some basic checks in terms of the root mean squared error and R2 score. All of them look good as now. Now we're going to convert this model into Onyx runtime. And then once that model is converted to Onyx runtime, we will be pushing the model to Azure SQL Edge. Our ML model has been trained and pushed to Azure SQL Edge. Let's do the analysis. So let me select all the queries. What we're doing here is simple data inferencing. We are going to just look at the last 10 data points that have been coming from this ECG monitor and analyze the heartbeat based off the model that's being trained. Let's run it. Voila, here we have the last 10 readings from the portable EKG monitor. Now that we have seen this person has a heart rate classification of 1, she is not in any danger at this point. However, heart rate is classified from 0 to 4. It's at points of 3 and 4 where it's considered to be of a high risk and the person can actually get a heart attack. Now that this person has gone to the doctor and can check it, this is where we come to the ACT stage. In the ACT stage, there are 2 things that can happen. 1, the patient goes to the doctor that is closer to him or her given their location. And the second thing, the moment they come to a place with internet connectivity, the data gets synced with the patient portal. Once it gets synced to the patient portal, her primary care physician has end-to-end understanding of what happened between her 2 consecutive visits, thereby providing a much more personalized medical attention and medical care. With this, we have seen how Azure SQL Edge can provide a smooth, easy, and really engaging remote medical assistance to the patients. This slide over here shows how our customers are currently using Azure SQL Edge and have thus transformed their businesses. It has played a key role in improving their factory efficiency, cost savings, enhancing processes, making employees more productive, and accelerating their client delivery time. In short, Azure SQL Edge is enabling customers to move to Industry 4.0. I just want to take some time to summarize Azure SQL Edge. So this product simplifies edge architecture and IoT application development for customers by supplying a small footprint data engine that runs on a choice of platforms, delivering consistency in data, tooling, and security from edge to cloud. Powerful enough to run offline, but with the capability to connect seamlessly to broader network of services, Azure SQL Edge has built-in ML AI capabilities, support from time series data, and native data synchronization with SQL Server and Azure services such as SQL Database, Cosmos DB, etc. Customers have a small but powerful data engine that meets the challenges of IoT, which empowers businesses to use and analyze data collected at the network edge, so thereby reducing costs, driving innovation, improving safety, and gaining competitive advantage. And with that, you can learn more about this product on our documentation page. You can also try out Azure SQL Edge as it is currently available on our marketplace. If you would like to learn more about this product in action, please head to our customer stories. And with that, thank you very much for your time, and I hope you enjoyed today's session. Hi, everyone. Thank you so much for joining us. I have with me Saurabh, who's the lead program manager for Azure SQL Edge. Saurabh, do you want to introduce yourself?
Yeah, sure. Absolutely. Thanks, Sia. Hey, everyone. My name is Saurabh Agarwal. I lead program management for Azure SQL Edge within the engineering team at Microsoft.
Got it. So today we saw what Azure SQL Edge is and the multiple features it brings to the table. And today was when the product went GA. So having said that, the most important question that we are getting from customers and partners around us is pricing. How is Azure SQL Edge going to be priced?
Right. That's a good question, Sia. And pricing has definitely been one of the top questions we have heard from our customers and partners. And the pricing for SQL Edge is pretty simple, right? It's offered at a nominal price of $10 per month. And there are pricing options for a yearly and a 3-year subscription. That's for the connected scenario. In the disconnected scenario, customers can buy SQL Edge at a subscription price of $100 per year through their EA subscriptions or through their volume license subscriptions. Now, there are different pricing options available for OEMs and distributors, but in the interest of time, let's not get into the details of those pricing options. Pricing one thing, right? And then what I've generally heard from customers or questions from customers is around availability, specifically around what regions SQL Edge is available in and how customers can procure SQL Edge and go about it, right? So,
Got it.
Sia, why don't you talk about the availability of the product?
Yeah. So when you look at Azure SQL Edge, it's a twofold deployment. One, you can deploy it as a connected scenario, and then you can also deploy it in a disconnected environment. So when you look at connected scenario, Azure SQL Edge is available in all places where IoT Edge is currently available, except for China. And as we are talking now, there is a roadmap to make it available in China soon as well. In case of disconnected scenario, you can download the bits from Microsoft Container Registry. Instructions on how to do it is available in our documentation. Please go ahead and have a look at it. Now that we have touched upon availability and pricing, the next important thing, especially when it comes to IoT deployments, is one, you have a lot of data sitting on the edge, and it is very important to send that data to other targets, either be it on the cloud or be it on your on-premise server. So having said that, Saurabh, do you want to touch about this bidirectional data movement that we are building inside our product?
Yeah, absolutely. And you touched upon a very important aspect of Edge and IoT deployments where data needs to land in cloud or data center. There is a reason for that, right? Edge devices today, or by the nature of it, or where we are in terms of our technology stacks, they are still not at a scale where you would want to do analysis of petabytes of data, right? Mm-hmm. And that would not probably not be cost efficient and cost effective, right? So you would rather want to have that data land in cloud or a data center target and make use of the scale analytics which cloud offers, or the cloud economics part of it, right? What data do you move is a slightly more nuanced topic, right? There are scenarios where you would not want to move the raw data. You would probably aggregate that data and then move that data. There are also scenarios where once you have processed the raw data for regulatory requirements of other organizational requirements, you may still want to move all of that raw data. So data movement from edge to cloud is significant, or it's important. And as such, we are building a lot of capabilities within the product to allow you to do that. A lot of it depends on what your targets are and what the volume of data you're trying to move to a cloud or a data center target, right? So today, there are existing mechanisms through ADF, Azure Data Factory, or Azure SQL Data Sync, or you can build your custom modules using PowerShell, C# or Python or whatever it is, right? And then we are working in the future to add more capabilities around data streaming, where we would allow you to, or where would we provide mechanisms for you to use data streaming to do that data movement to a cloud target or a data center target in your data state. Right, so, talking about data movement, right, and data itself, IoT data is, a lot of the IoT data is time series specific, right? These are essentially time events and recorded, in order of time, right? And given that you are very close to the time series capabilities of SQL Edge, why don't you talk about some of the capabilities we are introducing in time series, or the time series aspect of it?
Sure. So as a whole, Azure SQL Edge's time series capabilities is twofold. We bring to you the time series features that is already available through Azure Stream Analytics, such as aggregation, windowing function, etc. And when window functions include tumbling, hopping, sliding. So what happens is you can aggregate events over multiple windows and then go ahead and process the data based on what you want to do. And then when it comes to the SQL engine itself in Azure SQL Edge, we have brought specific T-SQL constructs and storage optimizations into picture. So first and foremost is date bucket function. So this date bucket function helps capture that time series data, store it, and then helps you go ahead and do querying and processing that's required. The next thing is we have brought this capability of filling in missing values. So when you look at time series data, there is always a case where there are gaps or when data is missing, and this is especially because of the nature of data collection or the nature of data itself. So ability to fill that missing data using either the previous value or next value is very important when it comes to analyzing that. And then finally, we have what is called as data retention. So when we spoke to our customers, from big organizations, etc., we realized that it's very important for these companies to carefully plan the amount of data that they want to retain at the edge, and also understand to what level of granularity that they want that amount of data that's coming from the IoT devices need to be stored at the edge. So when it comes to data administrators who are using Azure SQL Edge, they can actually set up something called as a data retention policy, and both on the SQL Edge database and the underlying tables. So once the data retention policy is defined, there is a background system task that will run and purge any old data from the user tables based on the timestamp that you have set over there. So having spoken about all of this in terms of time series capabilities and data movement, and you also touched upon data streaming, Saurabh. So do you want to talk a little more on the input-output target pairs that we have for data streaming?
Right, sure, absolutely. So today we support IoT Edge Hub, IoT Edge, and Kafka as an input for the streaming layer. And we are obviously constantly working to add more inputs, whether it's a SQL, whether it's a file, or a service in Azure. And then we are also constantly working to increase the number of output targets we support through the streaming. Today we support outputs to SQL and to IoT Edge, but in the future we are looking to increase that to Azure Blob Storage, Azure Cosmos, Azure Synapse, data services within Azure ecosystem, and also to products running on your data state in on-premises, like maybe a file system on your NFS or a SQL server in your data state and stuff like that. Right. I think in the interest of time, we have the time we have left is for one question, and I think the best question to take up in this time frame would be around tooling and experiences. And Sia, you being at the forefront of all our tooling and developer experiences, why don't you talk about some of the stuff we are doing in terms of our tooling and developer experiences?
Of course. So we have already established that Azure SQL Edge is built upon the same code base as that of Microsoft SQL Server and other Azure SQL offerings. So what that means is your tooling and developer experience is going to be consistent across the whole platform, that is from the edge to the cloud. Whatever tools that you're currently using for your SQL Server instances and Azure SQL is something that's going to be working for Azure SQL Edge as well. So what we have is Azure Data Studio. So as a baseline, we all know Azure Data Studio can be used for connecting and querying from your Azure SQL Edge instances. But we are enriching this experience to cover multiple scenarios specifically for Azure SQL Edge. And this includes deploying a local container or even scaling the deployment to devices that are all connected to the IoT hub, especially in the connected scenario. And additionally, we are also looking at a future roadmap where we will be creating Azure SQL Edge solutions with Azure Data Studio projects. I'm really excited for that, and I hope our customers are also excited for that. I think with that, we are almost at the end of the 30-minute. So thank you so much for having us over here. Saurabh, any last words from you about the product?
Yeah, I mean, first, thank you for the opportunity, and thank you for spending your 30 minutes of your time with us. I'm excited about SQL Edge and the possibilities and the solutions which you can build on SQL Edge. And I'm looking forward to hearing from our customers and partners on how best they use the product to build amazing solutions.
Yep,
Thank you, everyone.
definitely. Thank you, everyone.